Okay, so let's look at the solution to the activity. So we want to calculate the net electric field at the dot in the center due to the two charges. So the first thing that we do is we draw, let's call the charge at the top charge 1 and the charge at the top charge 2. Draw the electric fields due to them. So again, electric field comes out of a positive charge towards that one. So E1 is going to be away from the one in the top corner, and it goes into a negative charge. So E2 is going to be towards charge 2. So we've got our directions. Now we're going to calculate the magnitudes. So E1 is going to be K Q1 over R1 squared, and E2 is going to be K Q2 over R2 squared. So one thing we know is by looking at the symmetry, the charges are the same, just one's positive and one's negative, and the distances should be the same. So that means that the two numbers that we get for the electric fields should be the same. Again, we're going to just calculate the magnitude, so we're going to ignore the signs. So we can put absolute values signs around the Q there. So we know the charge. What's the distance? Well, the distance R1 is half the diagonal of the square, and R2, let me change my color here, is also going to be half the diagonal of the square. So if the square has 1 meter sides, okay, then if I zoom in a bit, you can see that R1, if I make a square, and R2, if I make a square, they're going to be 0.5 meters on each side. Okay, so the length of R1, we use Pythagoras, is going to be 0.5 squared plus 0.5 squared, and same thing for R2. So R1 squared is going to be equal to R2 squared. It's going to be equal to 0.5 squared plus 0.5 squared. So 0.5 squared is 0.25, 0.25 plus 0.25 is 0.5. So R1 is going to be equal to R2. It's going to be square root of 0.5, which is going to be 0.707 meters. Okay, so we've got R1, we've got R2, and we've got the charge. So now we can just put our numbers in. So E1 is going to be K, 9 times 10 to the 9, times Q1, which is 2 microcoulombs, 2 times 10 to the minus 6, over R1 squared, 0.707 squared, which is of course going to be 0.5. So I get 36,000 newtons per coulomb. And for E2, I should get exactly the same number, but let me just go ahead and do it. And again, I'm going to ignore the fact that it's a negative charge. And so I get, again, 36,000 newtons per coulomb. Okay, so we've got our arrows, we've got our magnitudes. Next thing we do is X and Y components of each one. So if I look and I draw a picture, so if I draw a picture of E1, it's going down towards the bottom right, and it's on the diagonal. So this angle is half of 9 degrees, 45 degrees. Okay, so E1X and E1Y are going to be the horizontal and vertical sides. So E1X is going to be E1, and the X side is opposite to the angle, so it's going to be sine 45. And E1Y is then going to be cosine, E1 cosine 45. Okay, and if I put in my numbers, then E1x is going to be 36,000 times sine of 45, and I get 25,456. And for E1y, 36,000 cosine of 45. I'm going to get exactly the same number because sine and cosine of 45 are both the same. Okay, now the x component is positive because it's going towards the right. The y component is going down, so it's negative. Okay. If I do the same thing for E2, now E2, let me just switch my color there. Let's go to a green. So E2 is going down diagonally to the left. Again, the angle's 45 degrees. So E1y, so E2y, and E2x are those sides. So E2, the x component, is going to be negative because it's going towards the left, and the y component's going to also be negative because it's going down. And E2x is opposite, so it's going to be sine 45, and E2y is adjacent, so it's going to be cos 45. And because E2 is the same size as E1, we can get the E2x is going to be equal to 25,456 again. And this time it's going to be negative because it's going backwards, going in the left direction. E2y is also going to be negative because it's going down, 25,456. Okay, so now what's the next step? Now we've got in components, we add them together. So the net x component is going to be E1x plus E2x. And of course, E1x is plus 25,456. E2x is minus 25,456. And so that just cancels out and we get 0. And of course, that's what we'd expect, right? Because we've got two equal vectors, one going to the left, one going to the right. The horizontal components going to cancel. How about the vertical components? Well, those are both going down. So those are going to add together. So I've got minus to indicate it's going down, 25,456 minus 25,456. So I'm going to get a net negative 50,912 newtons per coulomb. So what's the direction? The direction, we've got no x, we've got all y, and I should put a minus sign in front of there. Direction is straight down. All right, so straight down means it's minus 100. Not minus 100, minus 90 degrees. From the plus x direction. So again, remember, when you put your answers into the homework service, it always wants an angle from the plus x direction. So if you're in quadrant 1 or 2, you're going to give a number between 0 and plus 180. If it's in quadrant 3 or 4, you're going to give a number between 0 and minus 180.